We're going to look at research methods. By the end of this topic, this is our fourth topic. By the end of this topic, you'll be able to explain the difference between research methods and research methodology. And you'll be able to describe different research methods depending on the type of methodology that is being used. You shall be able to describe the process of conducting a research survey. We shall go into that method in detail. And then we shall also understand what research validity is all about. Now, we may not cover all this today, but we shall see how much we can cover. So by now, we have gone through the idea, I hope you all appreciate the idea that the research process begins with reviewing of available literature so that you can be able to formulate a research question or problem. And then the next step is to select an appropriate research design. So the research design is how you're going to answer the question, or is how you're going to solve the problem. And yes, so today we're at that third step. We're understanding how you go about that third step. So now research is complex and there are many varieties of research, types of research. So the variety and complexity of research situations and issues requires researchers to be familiar with a fairly wide range of research methodologies and methods. So what is a research methodology? A research methodology is a collection of theories, concepts, or ideas as they relate to a particular discipline or field of inquiry. So their words to note is the fact that a methodology is tied to a discipline or a field of inquiry. And a methodology includes research methods used, the justification for these methods, the assumptions underpinning in any particular study. So a research methodology has methods in it. And a method is a strategy of inquiry which moves from the assumptions to research design or plan and data collection. So the research method will tell you how you design the research and how you collect data. A research methodology has in it many methods. And the research methodology comes from the discipline that the research is from. So on this slide here, you can see we have here this word philosophy, the way to think about it. And then we have methodology, how to study it. Basically, the way of how to study it. So different disciplines have a different way they look at research because they're answering different type of questions. Like the research that you do within the arts is not the same kind of research you do within the natural sciences. So the natural sciences, this is agriculture, biology, medicine, geography or geology. The kind of research you do there is different from the type of research I said you do within the arts, or within the social sciences, or within the linguistics, within the statistics. So different disciplines have, first of all, a way they think about research, different philosophies. These are these kind of oval-shaped things. There are different philosophies, ways of thinking about research. And then out of these different philosophies comes different ways of doing work. So I'll come back to this natural sciences. I said that here we have things like biology, chemistry, and their research is largely quantitative. And the methods under there, we have experiments, field experiments, quasi-experiment. Then we have some surveys there. But these are quantitative methods, and they fall under the quantitative methodology. And so here, yes, you are looking at things that can be measured, or you want to measure, and then you test and prove hypotheses. Yes. And then we have the technical sciences, and this is where we largely fall. IS, computer science, engineering. This is under the technical sciences. And if you follow these arrows or these dotted lines, well, it ends up here, combined designs, Quan or Qual. So here we use a mixed method, a mixed methodology that combines both qualitative and quantitative ways of doing work. And then here we have the qualitative methodology. Under it are all these methods that you're seeing up here. All these ones: case study, grounded theory, discourse analysis, phenomenology, many qualitative methods. These methods work well for anthropology, humanities, all these kind of disciplines. They use qualitative methods. And so, point to note is that there are so many research methods, depending on the methodology, and the methodologies vary. So we have two types of methodologies, and then a combination of those two. So there are three methodologies. And then out of these come these so many methods that you're seeing in squares here. Somebody had a question for me. Oh, not somebody had typed in the chat. Okay. Or somebody had put up their hand. Okay, so that is, and again, the methodologies vary from discipline to discipline. Okay, so the methods used in research differ from discipline to discipline, depending on, this should have been on the methodologies. And there are mainly three methodologies: the quantitative methodology, the qualitative methodology, and the mixed methodology. So from the quantitative methodology comes the quantitative methods. And from the qualitative methodology comes the qualitative methods. And the mixed method uses both qualitative and quantitative research methods. So the mixed method, you use both to achieve whatever goal you have. So in designing a research, after you've got your research aims or problems, next is to determine what methodology it will be. Will it be quantitative? Will it be qualitative? Will it be a mix of both? And then after you've done that, you determine what methods you'll use because even under the quantitative methodology, which this slide calls approach, there are many methods. So you determine what methods you use. Either they will be qualitative or they will be quantitative. And then you determine, then you collect the data depending on what method you use. So the different methods give you different types of data. So this is now where we are in the research process. I'm hoping that you're working on it, or at least you have research aims, problems, because they determine what kind of methodology you'll use, and then what type of method you'll use. So first, we're going to look at the qualitative methods. So qualitative methods are used to manage qualitative data for understanding and explaining social phenomena. For example, data from interviews, documents, and participant observation. So the interviews, documents, participant observations are how you get the qualitative data. And these qualitative methods include case study, action research, ethnography, and grounded theory. Okay. Sorry, this slide is at the wrong place. Okay. I wanted us to first just watch a brief video about methodology. I noticed I put the slide in the wrong place. So let's first watch this video on methodology. If I can continue with the different methods. And we just put this slide where it belongs. Right here. Just a minute. Okay. Yes, I just want us to watch a brief video on research methodology and method. So by now we know that methodology means qualitative or quantitative. And I could click it here so we watch it together. Okay. Let's wait a minute. Let's wait a minute.
Look familiar? A long day of teaching, followed by hours of grading at home. It's time. Hello there, everybody, and welcome to the Mr. Sin channel. In this video,
Okay, I don't know what you're seeing. You end. Are you still seeing PowerPoint?
Yes.
Oh, you're still seeing PowerPoint. Okay.
Yeah.
Let me share this other. Okay, it's a brief 5-minute video.
we're going to be going over qualitative and quantitative research. We're going to be talking about what both of these types of research are, how they're different, and also how they're similar. If this is your first time watching Mr. Sin video, welcome. Hopefully you find value in this video. If you do, please consider liking the video and subscribing. Also, make sure you take notes throughout the video. You can use your own notes or you can use mine. I have guided notes that I've created that go along with all my videos. You can find them in the description below. But this video is about qualitative and quantitative research. Now, they're both pretty similar, yet very different, and it's important to understand the differences between them. Qualitative research is going to be focusing on things that are up for discussion and for debate. It's going to be describing a lot of things. It will use surveys and observations and interviews, along with also looking at artifacts of an area. It'll look at language, it's going to look at religion and ethnicity, it's going to look at these things from a manner that is up for discussion. Where quantitative is going to be trying to definitively prove something. If a geographer, for example, is looking at an area, it's going to look at the economic data, the political description, it's going to look at population breakdowns through age and gender, or even looking also at things that are just concrete. These are things that are facts. You can't dispute them. They're not up for debate. When it comes actually to the research part, qualitative is going to be asking more questions that deal with what and how. They're going to be asking more open-ended questions. For example, how do people living in inner city view their country? Or how do AP students celebrate finishing the AP Human Geography test? These questions aren't necessarily going to have a hypothesis because we're not trying to predict anything here. We're trying to gauge and understand better the society around us. Quantitative, on the other hand, is looking at research that is going to be looking at variables, and it's trying to either prove a hypothesis or possibly even disprove it. Here, questions are going to be asked a little bit differently. Questions are going to be focused around what, how, and does. So for example, how much, how often, what is the relationship between the two? What is the percentage? An example question could even be something as simple as, what is the religious breakdown of the United States? Or how often do farmers go to the market to sell produce if the road is paved or if it's unpaved? Or does public transportation actually solve transportation issues within a city? These are all things I would look at statistic and numbers to be able to answer these questions, where qualitative is more of an exploratory form of research, and it's not necessarily defining and trying to prove or disprove a hypothesis. When it comes to collecting data, qualitative is normally going to use one source to collect data from. Maybe it's newspapers, journals, it might be observations or interviews, or even audio and video materials. Now with qualitative, they can change things up throughout the study if I notice they're not getting enough responses from one area. Quantitative, on the other hand, is just using numbers. They're looking for things to prove something right or wrong. So they're going to be looking for more statistics and things that are concrete. Lastly, when it comes to analysis and also the final report, qualitative is going to be set into themes. See, researchers are going to take all the observations, all the information they collected, and try to break it down into different themes. This is very time consuming. And the final report will have a lot of writing in it. It's going to have a lot of quotes and different things that they observe. And it will be up for discussion. The participants will be very involved in it. Where quantitative, on the other hand, is not going to have that many words. It's going to be taking an analysis portion, all the different data points that they collected. Then they're going to break it down to see if there's any statistical significance behind any of the information they gathered. Then they will have a final conclusion that'll either back up the hypothesis or go against it. The quantitative report is going to be a lot more rigid. It's not up for discussion or debate. It's just showing the findings of what they found. There's less interpretation there. And that's it. This video was a really quick overview of qualitative and quantitative research, but hopefully it helped you understand all the basics about these two different.
All right, so I hope you now have a better understanding of the two methodologies. Now the video never spoke about the mixed method, but yes, mainly you'll find that it will always be the talk of the two, either qualitative or quantitative, and then mixed methods, you design the research as you go along to make it a mixed method research. All right, so let's continue unless I have some questions. Unless you have some questions for me. No, you don't. All right. So now let's begin to look at the qualitative methods. So at least you've seen which kind of situations you'd want to do qualitative research. And the methods that you have that we can use, we have case study, action research, grounded theory. And then for the quantitative methods, these are methods that are used to study natural phenomena that can be measured. And these quantitative methods include surveys, lab experimentation, numerical methods, formal methods. For our course, we shall only look at the surveys and the lab experimentation. So we begin with the case study method. So case study is typically applied in socially related research, or at least as much like where it came from. It involves an in-depth study of a single individual, group, incident, or community. The case study is the most common qualitative method used for information system research as well. The case study is an inquiry that investigates a contemporary phenomenon within its real-life context, especially when the boundaries between the phenomenon and the context are not clearly evident. So with case study, you study a case, maybe, and it is a single individual or a group or an incident or a community. If you want to look at how HIV affects people, you can study a single person, a single mother who is struggling, HIV mother, and then you study that one. For IS, let's say you want to develop develop a hospital system, that hospital that you go to and you study, that is now the case study. And with case study research, the researcher gives the research product to others to use in the field to achieve some goals, as in the researcher gets knowledge and then other people can use this knowledge. If, for example, it was about the HIV mother, they will study the HIV mother and then this knowledge will be used by other people. Though this sentence doesn't tend to apply if it varies. If it's an IS, you may study the case and then use it to make the software. So it's a small one. So case study is an empirical method aimed at investigation of a contemporary phenomena in its context. That's the idea, that you look at this, whatever you're studying, within its context. You don't like move it away from there. It's within its natural environment. And it has some steps. So you have, first you design the case study, then you collect the data, you analyze the data, and then you develop a conclusion. And within the case study, you can use other methods. Now that's where it becomes interesting. So within a case study, you can use a survey, you can use the literature review method within a case study, and you can use ethnographic methods like interviews and observation to collect data. If you want to read up more about the case study, there's some paper there that talks more about the case study method. And then we have action research. So just as the word sound, action and research. With action research, it's an attempt to solve a real-world problem while simultaneously learning from the experience of solving that problem. It is carried out in a real-world context with the researcher as part of the organization during the investigation, so solution development and solution application. So with action research, let's say you have an organization that is having a problem. It could be a human resource or human resource problem. So you come as a researcher, you're a human resource researcher, and you're also a human resource expert, or at least you know some human resource theory. So you are part of the organization to investigate the problem, and then together with the management of that organization, you propose a solution, or you design a solution together. Typically, as a researcher, you should know maybe some theories that you want to investigate, and now you're using them there. So you use those theories to implement this solution, and then you develop the solution, and then you implement it, and then you learn from that experience. So in order to have this action research, elaborate to identify both identify a problem and to engage in the effort of solving it. So with action research, you need the problem owner to be willing to work with you, the researcher, in identifying the problem and then solving it. Action research has 5 phases: diagnosing, action planning. So those are the phases. You identify or you define the problem, you plan a solution, and then you take action depending on what you've planned. Then you evaluate. So if it had been that human resource example I said, after you implement whatever I said, maybe people should do like this. Instead of coming at this time, people should do this. People do what you've said. You evaluate what has come out. If things are better now that you made that solution, and then now you specify the learning. Now this is where the research part comes in that there has to be some new learning from this process. So action research is a reflective process of progressive problem solving. To a community of practice to improve the way things are done. Action research aims to contribute to both practical concerns of people in an immediate problematic situation and to the goals of, well, there it's social science, but really not just social science, but to the goals of knowledge, of academia. So with action research, you solve a problem while you also come up with new knowledge. The researcher uses the research product in the field to achieve some goals. What that means is that the researcher, whatever knowledge they got, they use it to achieve some goals, which are solving this particular problem. And then we have ethnography. Now, ethnography comes from the discipline of social and cultural anthropology. And the two words are ethnography. Ethno meaning people, or ethnos, and then graphy, study. So ethnographers spend their time in the field immersing themselves in the life of people they study, placing the phenomena studied in their social and cultural context. So with ethnography, it's about studying people in their real life, in their real social and cultural context. The researcher acquires in-depth understanding by seeing what people are doing, as well as what they say they are doing. So with ethnography, the ethnographer has to live with the people and sees what they are doing. And they collect a lot of data, they observe what people are doing, they write, they take journals of the events that people think they're saying and they are doing, and they collect all this data and analyze it. So ethnography is systematic and often uses fieldwork, whereby fieldwork is a collection of information outside of a laboratory, library, or workplace setting. The approaches used in field research vary across disciplines, from disciplines. So basically, you can do fieldwork in any discipline. The idea with fieldwork is that you're not in a lab, or you're not in a library, you're not in a workplace setting, you're out there where whatever you're studying is. In basic terms, ethnography is the practice of anthropological research based on direct observation and reportage on people's way of life. So the key thing there is that you have direct observation of people and you report after. So the ethnographer, for ethnography, there are two stages. There's the fieldwork, which is the process of observing and recording data. And then there's a production of the written description and analysis of the subjects under study. The ethnographer spends a significant amount of time in the field with his subjects, his or her subjects, and immerses his or herself in their lives while they're studying. Of course, you need to win people's trust to be with them. You could spend either 6 months, a year studying them, and then after that, you write about them. Then we have grounded theory. And this is a systematic research method in social sciences that emphasizes the generation of theory from data gathered in the process of conducting research. So grounded theory, one is that there has to be a theory developed at the end of the day. And yes, you have data that you collected, and then from that data, you added some more literature, and then you have a theory. So grounded theory is a practice of developing other theories that emerge from observing a group. Theories are grounded in the group's observable experiences, but researchers add their own insight into why those experiences exist. So it's grounded in the sense that it's grounded in the experiences. And the stages within grounded theory is that you first identify the area of interest that you study, and then you collect data pertaining to this area. The data you may collect may be qualitative, so you might, you might have quantitative data, or you might have a mixture of the two. So let's say you want to understand, you want to come up with a theory that explains behavior of children. So you collect data on these children, and then you collect data on these children, and then you analyze it. For qualitative data, this open coding the data is a process, it's part of qualitative analysis, and we shall understand it better. So you analyze this data. So steps 1 to 4 are all part of the qualitative data analysis process, which we shall look at in detail. But the point is, you analyze this data. Then step 5, you read related literature and integrate it with what you got from your data, with whatever theory you had got from your data. And then after that, you can write up your theory. So you have data, read literature, have final theory. Or you have data, then you have a kind of a theory that you've seen from the data, whereby theory means an explanation of why something is happening, the way it's happening. Then you read literature and relate it to your theory, and then you come up with your final theory. So those are the 4 qualitative methods we have looked at. If you go back to this other slide, I said where is this slide? Yes, there are so many qualitative methods, but we have just looked at grounded theory, case study, and we have looked at action research. It is down here, and it falls under the combined designs, combined way of doing things. And yeah, okay, that's a method. Okay, I don't have to say that. But yeah, we have looked at these methods. Bear in mind that there are so many that we haven't looked at, reason being they don't really are not used in our discipline. Okay. Oh. All right, Stephen, I don't exactly get what your comment is in the chat there. Okay, but I've said now we have looked at the qualitative methods. So next we're going to look at the quantitative methods, especially survey and experiments. Okay, so we look at the survey method. So a survey is a collection of standardized information from a specific population, usually by means of a questionnaire or interview. So it's a research method in which questionnaires or interview guides are used to gather data about people, their thoughts, and their behaviors. That is of a sample of data opinions considered to be representative of the whole population. So you have a whole population that you want to study, but you gather data from a sample. This information is collected primarily by asking questions. Yes, from the sample. And why do we conduct surveys? To describe characteristics of a population. You want to know in Uganda, how rich or how poor are people? How many earn this and how many earn this range? How tall, how short, how all this kind of details about people. So, and the researchers use surveys to examine the distribution of the identified characteristics within a population. So after you get your data, you can now see how rich people are by just looking at the numbers, how poor they are by looking at the numbers. The description of the population is inferred by the results obtained from the sample, meaning that you study a small part. If you want to study Uganda, you won't collect data from the whole of Uganda. You collect some, and then you infer about Uganda from this data. And surveys may be used for descriptive, explanatory, or exploratory purposes, meaning that surveys may be used to describe a population, they may be used to explain why something is happening, or they may be used to explore and just to get a general overview of what is happening. They are typically used in studies that have individuals as a unit of analysis, as in when you're collecting data about an individual most times. And even if, let's say, you're studying a hospital or in your survey, you wanted to know about hospitals. And so you have a number of hospitals you're going to collect data about. Still within these hospitals, you will have to find some people to finally talk to. That's what it means that these people serve as respondents or informants, and they will be representing the hospital. What are the strengths of survey? So it is the only way to probe the opinion of a very large group. So if you have a very large group to study, you cannot say you're going to observe them or you're going to do a case study. I mean, any of the other methods we spoke about just can't work. If you have a large group to study, survey is the way. Then it's a very flexible tool. It can be used for medical, educational, political, business, any kind of discipline. Then it facilitates hypothesis testing, because since you have this data, standardized answers, and you can be able to test your hypothesis very well. You cannot do this for any of the qualitative methods we spoke about. And then it encourages standardization and systematic comparison. So if you conduct a survey and then you have data about from men and then you have data from women, if we are to use that economic status example I used, then you can say, right, let's see the data for the men. How much do they earn? Then the one for the women, how much they earn? Then you can compare, because you have the same kind of standard answers. Now, there are weaknesses. Of course, the standardization comes with a price in that you leave out a lot of detail. You may not get to know why people are doing the things they're doing. The respondents may not have an opinion on something you want to ask them, and you ask and they don't know, they don't have an opinion on what you're asking. They may not actively engage, and they may lie. So there's no, people may lie. It's something that, let's say if you had been doing any of the other qualitative methods, you're observing, you can easily see if somebody's lying. They told you this, but they are doing this. It's not something you can do in survey. You just go with what they said. So within survey, there are also steps. Again, first define the problem that you want to study, and that this will come from your problem statement. And then identify the population that you study. This should be a population where your problem lies. A population is the big group. Then choose the type of instrument you'll use to collect the data. Are you going to use a questionnaire or are you going to use an interview? And then design, construct, and pilot, and refine the instrument. By design, meaning if you're going to use a questionnaire, make the questions and then pilot them, ask a few people the questions that they understand, so that you know if they understand what you're meaning, and then improve it based on their answers. So after that, you have your questionnaire ready. That is now called the tool for collecting the data. Select a representative sample. You select a representative sample. You administer the data. So you administer the survey. That means you collect the data. Then you analyze, interpret, and communicate your findings. So those are the steps within the survey research. Then lastly, we have experimentation. So experiment is the typical research method used in natural sciences. It may involve definition of a theoretical hypothesis, then selection of the sample, allocation of the sample, and control on other variables. So then experiment, you're looking at some variable, then you keep something else constant. Let me say you want to see if people are in a cold room, they will freeze. Or if they freeze, if you put people in a cold room, they will freeze, and let's say their eyes will become their skin will become blue. I'm just using a vague example. So you put some people in the cold room, and then you put others, they don't enter that cold room. That is the control group. They don't enter the cold room, and then you look and you collect data from those who are not in the cold room and those who are in the cold room. You see their eyes. That's what we mean, that you have control on other variables. You keep some variables constant as you see what changes. And then the different types of experimentation. So we have a lab demo where the researcher uses a product. So these kind of experiments, now all the terminologies being used here are more in light of software, or you've developed a product and you want to test it, you want to demonstrate, you want to see how it works. So the researcher uses product on realistic example in an artificial environment. It's a lab that is artificial environment, but you have your product and you use it on an example. You see how people use your app you developed in a lab. They use it while they're in the lab. Then you have a field demo where the researcher or the designer uses a product or a prototype in the field. You have developed an app, people use it in the field, and you see what happens or what changes on them. Then you have a lab experiment. Others use product in artificial controlled conditions to achieve goals set by a researcher. So the researcher developed this app, and then now they have people use it while they're within a lab. Other people use it. It is different from the other one, the lab demo. The lab demo, it was a researcher using their app. But with the lab experiment, it is other people using it. And then you have the field experiment, where the researcher gives the research product to other people to use under it. This shouldn't be under controlled conditions. I'll correct this. They use it in the field to achieve goals set by a researcher. So field experiment, you have other people using their product, but now they're in the field and they are using it according to what the researcher said. So that is experimentation. In both these cases, at the end, the researcher can collect data and then compare. And I've just explained it, let me say, generically. Yes, I've explained experimentation generically. So our task would now be to, at least for your research problem, begin to think about the research method to use and the data collection technique to use. We shall look again more at data collection technique, but at least begin to think what method is appropriate for your work. I shall come back to this task later. But all right, so those are the research methods we have looked at. So for now, we have so far looked at research methodology and research methods. And we looked at 4 qualitative research methods and 2 quantitative ones. For the next part of our lecture, we're going to look at the survey research method in detail. Just Okay, so I've said that so far we have looked at research method versus research methodology. We have looked at different research methods. Now we're going to look at the survey research method. We said that it's a way of collecting data from, you want to find out about a large group of people, but you collect data from a sample, and then you, from this sample, you conclude about the large group. So there are steps, I mentioned briefly the steps in the previous part of the lecture. So now we're going to go into detail of how you get the sample, how you do the sampling. Yes, so the steps in conducting the survey: you need to design the survey instrument or the data collection tool, whether it's going to be a questionnaire or it's going to be an interview. You determine the target population. This is the large group that you need to whose details you want to find out, and then you determine the size, the small group, the sample. You determine the error. What error will you be able to won't affect the quality of your research, and we're going to look at what sampling error means. And then you determine the confidence interval. How confident do you want people to be with your results? Then you determine the sampling method. The sampling method being, how are you going to collect this data from people? And you determine your data collection method. I think I should change this. It shouldn't be down here. We already did that. So after you've determined your sampling method, you have your size, you have your tool, you're ready to carry out the survey, and you process the results from the survey, and then you interpret those results. So designing a research survey. Since it is often expensive to cover all units in the population, a sample can be studied, and then the results from the experiment on the sample is inferred. So the results from the sample are inferred to the entire population. However, the success of any research project depends on the way you selected the units. So let me say you want to study Uganda, but you cannot collect data from the whole of Uganda. That's what it means. It will just be too expensive, time consuming. You cannot ask every Ugandan. Then you just need a sample. However, the way you get this sample has to be very important, so that you don't only get from a type, from a certain group. You don't only end up asking only those who are in Buganda and you leave those who are in Karamoja. That's what sampling does for it. It makes sure that for the entire population that you have, every different group is well represented. So therefore, it is vital to know the various ways of selecting the unit objects to participate in a research survey, that is sampling. So it's important to know the different ways you will sample. And so it's also important to know the importance of the research process to the research outcome, that this data that you're going to get, what are you going to use it for? It is important to know that. Samples and population. Good sampling techniques maximize the degree to which the selected group will represent the population. That's the idea. You want the selected group to represent the population, and good sampling makes sure you do that. So a population is a group of potential participants to whom you want to generalize the results of the study. A sample is a subset of that population. When the results from a sample can be generalized to the population. So basically, after you've asked these few people, if from these few people, you can conclude about the population with a high degree of confidence. That is what you want. Then that means these results are generalizable. So when the results can be generalized from a sample to a population, then they have meaning beyond the limited setting in which they were originally obtained. When the results from the sample can be used to generalize a population, then now they have meaning. That's what you want. Generalizable results can be applied to different populations with the same characteristics in different settings. If you are studying the youth in Uganda and you got the sample that you used was good, it was a very good representation of the youth in Uganda, such that you could conclude about the youth in Uganda based on this sample, then you can make a conclusion about youth in Kenya. If you find that, well, it's already much the same kind of same characteristics, though we're in different settings in Kenya, but we can conclude about youth in Kenya. You can even conclude about youth in Africa if the sample was well mixed. That's what it means. So it's important to sample well so that you can generalize to the entire population, and then you may even be able to generalize for other different populations. So a good sample should have a high degree of representativeness of the larger population. It should represent the larger population very well. So before selecting a sample, the population should first be divided into non-overlapping parts that are called units or sampling units. Then these sampling units, a list of them is called the sampling frame. So if you're going to study people, Kampala, then you divide the population into non-overlapping parts, which are called the sampling units. In this case, there will be people, because a human being is one human being. You cannot have that this person is overlapping the other. That's what we mean by the non-overlapping. Those are the people in this case. And then you make a list of them. That is called a sampling frame. Non-overlapping means that every element in the population should belong to one and only one unit. A unit can be an individual person, it can be a firm, or it can be an organization. Let's say if you wanted to study the health sector, then your units are hospitals. They're non-overlapping in the sense that you cannot have Mulago Hospital, cannot be Mengo. There's no mix up in there. That's what we mean. So you need to first have that, the units, and then the sampling frame. And then we shall see later how that sampling frame is used. Now, in case you did not sample very well, results are not generalizable if the selected sample is not an accurate representation of the population. If you have your sample but doesn't represent the population well, then these results that you got from there, you cannot infer them to the population. If results are not generalizable, they are applicable only to the units or objects that were sampled. You wanted to get a representation of the youth, but you ended up studying only Baganda youth, then your results won't be generalizable. They will just only be applicable to that sample. So in every survey, it is important to assess whether the sample selected from a population appears to have the characteristics of the population in the same proportions, such that in that effect, the sample should be a mini population. And the purpose of sampling is to make an inference to a population based on a smaller sample. I've said this in many ways, but yes, it is important. So you want to make sure that the smaller sample is a mini population such that the data you get from this small sample can represent the population. Now, to do that, there are different types of sampling strategies, and they are characterized under either probability sampling or non-probability sampling. So probability sampling is whereby the likelihood of any one member of the population being selected is known. The likelihood is known. And there we have random selection, such that the selection of the participant is determined by chance. That is non-systematic or non-random rules. And because of that, there's a high possibility that the sample is a true representation of the population, because one, since it's each member of the population has this a known probability of being selected, and so you can choose randomly and you have a true representation. Then under the non-probability sampling methods, here the likelihood, probability of selecting any member of the population is not known. Therefore, potential members in the sample do not have an equal or an independent chance of being selected. So each unit doesn't have the same equal chance of being selected. Now, I'll first begin by looking at the probability sampling methods. We have simple random sampling, and it may be with replacement. That means you pick randomly and you replace, or you pick randomly and you don't replace. So we have that is simple random sampling. We have systematic sampling, stratified sampling, and cluster sampling. We are going to look at those in detail. But before we do, we can watch a small video. Sorry. Let's put this. Just a minute, sorry. Okay, just a minute, sorry. The video that I had is not coming. Okay.
My name is Ariel, and I just started my first job as a project manager. When I was a student, I'd write long essays that
Okay.
Recall that our population refers to the group of things that we want information about, and a sample refers to part of the population that we take out to examine and draw conclusions from. In this video, we will be looking at the different methods of obtaining a sample. But first, let's look at the types of biased samples. Biased samples occur when one or more parts of the population are favored over others. The two types of biased samples include the convenience sample and the voluntary response sample. A convenience sample only includes people who are easy to reach. If this is our population and a researcher comes along to interview people, then he would only talk to the people that are closer to him to be part of the sample. This is a biased sampling method because not everyone in the population has an equal chance of being part of the sample. Only people that are of convenience to the researcher will be interviewed. Now, a voluntary response sample consists of people that have chosen to include themselves in the sample. So the researcher lets people come to him. This is a biased sampling method because people with a strong interest for the survey topic are the ones who are most likely to respond, whereas the people who don't feel as strongly about the topic may not even care to respond. Remember that a good sample is one that is representative of the entire population, and it gives each thing an equal chance of being chosen. When you have these conditions, you have what is known as an unbiased sample. We will be looking at three different types: stratified random sampling, multi-stage sampling, and simple random sampling. The most basic type of sampling is the simple random sample, also known as an SRS. Since an SRS is unbiased, each individual has an equal chance of being chosen to be surveyed. In other words, to be part of the sample. You can think of an SRS as putting names into a hat and selecting N of them. So if I wanted a sample size of 6, I would select 6 papers and come up to the randomly chosen people to interview them. For a stratified random sample, we take the population and we divide it into something called a strata. Strata refers to the groups of similar people. Within each stratum, we take an SRS and combine the SRSs to get the full sample. For example, we could take an SRS of 2 people from each group so that we get the total of 6 people. A stratified random sample is good for making sure that whoever is administering the sample gets in contact with each kind of group. The last type of sampling is called multi-stage sampling. For multi-stage sampling, we use a combination of 2 or more simple random samples. As the name suggests, multi-stage sampling means you have to go through different stages to find where your sample comes from. For example, if we have 3 groups, stage 1 could be selecting which group will be picked using an SRS. Let's say that I picked out group 1. Then that means I would only look at group 1. Then for stage 2, I would do another SRS to get to 6 random people. We go through different stages of simple random samples to get the actual sample, and this is why this is called multi-stage sampling. I'd like to point out that instead of putting names in a hat, there's another way to pick things randomly. We can use something called the random digits table. The random digits table consists of a long string of random numbers, and it can help us do an SRS. To use it, I would first have to label each member of the population with a number. We have 30 people in this population, so I will label each person from 1 to 30. Notice how I have written 0, 1 instead of just 1. Doing this helps us use the random digits table. Since each label has 2 digits, we will read the string of numbers 2 digits at a time. So let's say I want a sample size of 4. We will use the random digits table to randomly select 4 people. The first number on the table is 19, so person 19 will be part of the sample. The second number is 22, so person 22 will be part of the sample. The third number is 39, but our sample size doesn't go up to 39, so we will ignore it. We will also ignore 50 and 34, but we will keep number 5. We will also ignore 75, 62, and 87, but we will keep number 13. As a result, these are the people we would survey.
What if ideas remained ideas?
Survey.
Buildings would be.
All right. Did you learn anything from that video? Before I can begin explaining, what did you learn from the video? Either put up your hand and say something or type in the chat. Or what words did you hear? At least you heard something, or the video was useless.
No, me, I had random sample.
You had random sampling, okay. Thank you. All right, types of sampling, stratified sampling, okay. Okay, so convenience sampling, all right. Stratum, simple random sampling, okay. This you had some words there. So this, now we're going to look at these in detail. Again, so the video was first talking about, was meant to talk about the probability sampling methods. And probability being that, where are we? Okay, bias and non-bias sampling, okay. Yeah. So we're going to begin looking at the different probability sampling methods. Probability being that, each member has a known chance of being selected, being part of the sample. Each member, each unit of the population has a known chance of being part of the sample. That's the probability method. So each one has a chance of being part. A part that has a chance that is known. So we're first going to look at the simple random sampling method. Here, each member of the population has an equal and independent chance of being part of the sample. It is equal, independent. So equal in the sense that there's no bias that one person will be chosen rather than the other. Everyone has a chance, whether male or female, young or old, or the same. It is independent, meaning that the choice of one person doesn't bias the researcher against the choice of another. If you've chosen a boy, doesn't mean that you won't choose another boy. You can still choose another boy. If you've chosen a male, you can still choose another male. Or if you've chosen a girl, you can still choose another girl. There's no such thing as saying that, okay, now because I've got a girl, I want to get another girl. That's what it means. It's independent. So in random sampling, the characteristics of the sample are very close to that of the population. So the population you want, the characteristics of the sample are close to the population you want. And it can be with replacement or without replacement. So steps involved: define the population that you want to select the sample from, list members of the population, assign numbers to each member of the population, and then use a criterion to select. I think you saw that in the video. We explained that use the random table. So he explained how you can use, that's the manual procedure of using a random table, or you can use a computer to help you tell you which numbers you shall select. Okay, here we have an example. We have random numbers being given in Excel, and then you just select randomly. So the video has a better explanation of how to use that random table. So at least I'm trusting that you understood from the video how you use that random table. So next we have stratified sampling. Sorry, systematic sampling. Here you are selecting every nth or kth number, as in is every after you select. But that means every kth name on the list for the target population is chosen, where k is a number between 0 and the desired sample. Steps involved in systematic sampling include: 1, determine the value of k by determining the size of population with a desired sample size. So let's say, bear with me. Let's say the size is 100, the population 100, and the desired sample size is 25. So meaning you have 100, but you want to have you want 25 samples. So you divide 100 by 25. So your k will be 4. So therefore, you will be selecting every fourth element of the population. So you just choose where you're starting from and you choose every fourth. Here you see that each member in the population has an unequal chance of being selected. So true, they have a chance of being selected, but it's unequal. It depends on who's lucky to be the fourth. Others, so it's different from their simple random, whereby everybody has an equal chance of being selected. Yeah, it is unequal. So on this slide, we're just saying that if you have, this is your population, and it's made up of a mix of people. Their religions. We are Protestants, Catholics, Jews. And they say each symbol has 100 people. So you have your population and you've divided it into clusters, and their religions in there mixed. Systematic sampling. They say just choosing every second cluster. You choose a second, you choose the fourth, you choose a sixth, you choose the eighth, and you have your systematic selection of clusters. Then from these clusters, you'll see the overall the sample of the people. Then more the Protestants. So you're trying to get a mix of the entire population, their faiths. You clustered them up. You chose the clusters systematically. So this is another way, or this is a way still of doing systematic sampling, just that you had your big population and you divided it into clusters, and then you systematically selected the clusters so that you have your entire sample. Then we have stratified sampling. Just a second. Okay, so we have simple random sampling and systematic sampling. We have talked about those so far, and they are good if the specific characteristics of the population are of no concern, as in it doesn't really matter very much if the fact that the population has people who are, some are young, some are old, it doesn't really matter. You just want people. It doesn't matter if the population has people of different faiths. It doesn't matter to your research. That's what it means, that the characteristics of the population are of no concern. You can use a simple random sampling or you can use a systematic sampling. However, if the individuals in the population are not equal in features, then stratified sampling should be used to ensure that the profile of the sample matches that of the population. Stratified sampling is used when factors that distinguish the population members from one another are related to the subject you're studying. Such factors include gender, age, race, religion. So if you're doing a study whereby the gender matters, and the answers that you'll get from a male will be different from those which you get from a female, then it's important that you distinguish the population, and you know these are of the population. It's made up of this percentage of male, it's made up of this percentage of female, such that when you do your sampling, you have a good representation of both. If I'm just to go back to this slide here, you see this slide here where we use systematic sampling. Finally, what we got here, if you see this, that represents Protestants, you have more Protestants than Catholics and Jews. But you don't know if really that is the true representation, whether overall in the population, whether you have more Protestants overall. However, this is okay if what you're studying has nothing to do with religion, so it doesn't matter. This kind of thing will be a problem if what you're studying was to do with religion, and yet the way your population is distributed, there are more Catholics. So let's say the population overall has more Catholics. And now for you, you did a sample that is like this. That would be a bad thing. So we are saying that stratified sampling helps you make sure you get the characteristics of the population very well. Stratified sampling ensures that the strata or layers in the population are fairly represented in the sample. Therefore, the sample is also layered like the population. So stratified sampling, the population is first divided into two or more mutually exclusive segments or layers based on some criteria or variables of interest. So let's say if it is gender, we first divide this, okay? Male, female. Those are mutually exclusive. One cannot be both male and female, at least logically. Just without the current confusion that some people have allowed themselves to fall in, but at least biologically, if everything is normal, you should either be male or you should be female. That's what it means, that it's mutually exclusive. Then you may be of one faith and not the other. That's what it means. So you first do that division. So these layers or subpopulations represent different characteristics. They should be non-overlapping and they should collectively make up the whole population. So you divide male and female, together you have the whole population. Each layer is called a stratum for single and strata for plural. Stratifying yields homogeneous subsets of a population. Now, homogeneous means that what you've divided in that subset, it's the only characteristic, as in you have now only males and only females. That's what it means, that it's homogeneous. So after you've done this stratified sampling, now you can, within the stratum, do simple random sampling from each strata, or you can do random sampling. Sorry, so if simple random sampling is used within each stratum, then the whole sampling procedure will be called stratified random sampling. So it is stratified that you first divided the population, and it is random that within the stratum you used random sampling. So we can go through the process of doing that. As we said, you list or group separately all members of the population that have the same characteristics. Let's say if you're working on using gender, you list males alone and females alone. Then you assign a number to each member in the group. For example, males have their number and then the females have their number. And then within the group, you use it as systematic or simple random sampling. So note that stratifying can be done on one variable, that is gender. It can also be done on more than one variable, let's say gender and religion. So you can even say now, males who are Muslim, males who are Protestant, males who are Catholic. So each of those will be its own strata. Then you have females who are Muslims, females who are Protestant, females who are Catholic, like that. Such that you end up having 6 strata. And then now you choose within there simple random sampling or systematic sampling within each. So for example, if you want to assess the impact of religion on honesty, so religion should be you stratify your population based on religion, and then use simple random sampling in each of the strata. Or let's say if you had a population that was children, P6, P5, P4, mixed. First you had it when it was mixed, children, primary school children. Now you first divide it, such that you have P6 alone, you have P5 alone, you have P4 alone. Then within there, you do simple random sampling, such that you have a good representation. And then we have cluster sampling. This is used when units of individuals are selected rather than individuals themselves. However, the unit of analysis is different from the primary sampling unit. For example, assume you want to study challenges faced by doctors in Ugandan hospitals. And a conclusive list of all doctors is not available for you to do simple random sampling. So first you obtain a list of all hospitals, then you randomly sample suitable hospitals, and then you randomly sample a number of hospitals from each of the selected hospitals. So you randomly sample suitable number of doctors from each of the selected hospitals. So still your unit of analysis is an individual, but you first began when you're doing sampling, you sample clusters. That's what this sentence is trying to say here. But the unit of analysis is different from the primary sampling unit. Your primary sampling unit is the cluster. Your unit of analysis is still the individual. Okay, so the units in the population must be homogeneous enough so that any difference in the unit does not contribute to a bias. Again, homogeneous meaning the same representational characteristic. So here we have an example, cluster sampling. The population again is divided. You see here Protestants, Catholics. Randomly select the samples, and then the final sample is like this. So of course the people who made these slides made sure that now the picture is different. If you look at what you have finally here, the Protestants are not too much more than the Jews. So the clusters have to be the mix. It shouldn't be like less than one or in one cluster have in others. This one, each cluster does have Protestants. You can see in most clusters, the Protestants are more, and some clusters don't have any Jews. So the idea is that the units must be homogeneous, fairly well mixed, so that you can easily just cut it into clusters. Okay, then we have the non-probability sampling. Here we say that non-probability, each member of the population does not have the same chance and doesn't have a known chance anyway of being selected. And yes, so we have purposive or purposeful sampling. This is used when there's need to study something about or features of a specific group of people. So there's a specific group of people that you want to study, and you choose specifically who those people are. It's not something that you can ask everybody anyhow. My friend was doing research on cement, miners in cement. You don't just go and ask anybody on the street. You have to go specifically to look for the people who are mining cement, and they'll tell you, they'll be able to give you the good people exactly have the answers. Then there's convenience sampling. This is the easiest way to select a sample where respondents are a captive audience. The sample generated is not a random audience, so a random sample, and may not be representative of a population, and may be representative only to a limited extent. So let's say you wanted to do research and you just say, okay, I'll go to Kamukamu Plaza there. I think I'll find so many youth. They always down there in town. And if you quickly find the youth, you ask for the youth that come to you, as opposed to trying to go and you go to the rural areas and make sure you get some from the rural areas, get some from the rich. If you just say, I think down there in the park, there's a mix. Let me just go there to the park, whichever youth, I'll interview that one. That is convenience sampling. Just you find where you can easily get. The challenge is the sample you get may not be representative enough of the entire population. Then there's quota sampling. This is suitable only when you need a sample that is stratified on certain variables. Yet proportional stratified sampling is not possible. As in, you cannot properly divide very well like how you would for stratified sampling, but yet you still need to get the different features catered for. So in this case, the researcher enlists individuals with desired characteristics until the desired quota or sample size. So let's say if you want to, you're looking at elderly people in urban areas. So it's all right. Maybe it's a male, I will get some 20 male. After you reach the 20 male, you say, okay, now let me get some females. So you're kind of trying to achieve the mix or to cater for the differences in the population, just like how stratified sampling does, but it's not proportional. So those are the methods. Okay, so we have looked at the different sampling methods. Maybe we might have a small break. What is the time now? All right. Okay, I'd want us just to go over that video now again, now that you have a good idea of what they are. Just go through one more time, or you ask me a question. Or is everything clear? I just continue. People are so quiet. Continue to sample size. Watch a video again. Do you have some questions for me?
Speed Munai.
Speed. But I'm trying to go slowly. All right. Continue now. Is it like too fast? How can I slow down? Give the video, watch again, and think about it and ask questions. A small break. All right, I can give a small break. Okay, let's have a 15-minute break. It's coming to 10. We can resume at 10:15. All right. I can give us a break.
So I got my essay written, and I've been working on it for about a week. So now I'm going to show you how I use Grammarly to edit. So here's the essay, and I'll click through Grammarly suggestions to the right panel. Your sentence may be unclear or hard to follow. Consider rephrasing. That's true. This is much better.
Welcome to this overview of qualitative research.
Good. Welcome back from the break.
Thank
All
you,
right.
madam. Welcome back to.
As some of you are logging back on, I'm trying to understand this thing people say I'm too fast. What exactly is too fast? Like, what are you used to?
Madam, maybe. Okay, actually, the speed you're okay, the speed you're okay, and so on. Sometimes people are in different locations. Sometimes their network break off, and when they come back, you have gone to another slide.
I see. Okay.
Yeah, and to add on that, today we have lectures paka.
Okay.
Yeah.
I see. Now what can I do for you?
No, the best way is recording. We can follow after.
Yes. Okay. The good thing, up to now, at least I sent all the recordings of these classes. But don't worry, I just want us to finish up everything we have, and then we'll be able to have some time to think through them. I just wanted to make sure you have everything you need. You see, when you're writing a proposal, you're proposing indeed the problem and everything, and then you also have to have the methodology, what you're going to do. So, well, next week, tomorrow we shall discuss more. Am I meeting you again tomorrow? Yes, I am. Yes. Tomorrow, I hope I shall look at your concept papers, and then we try now to think about how you have a methodology and how you. So let me I want to finish up on sample size calculation. Watch a few videos. I think we're together like for 30 more minutes. I think it's just the online way of doing things. Even who are working from home online work much more than they used to work in the office. Yes, you don't have a lot of time to waste. I don't see if you're dozing, if you're under your blankets. I have no idea. I just see these faces. I assume you're paying attention. And like in the physical, I'll be able to look at your faces and see that you're really fed up. But the faces I keep looking at are the same smiley faces. I assume you're as focused as your faces, as the nice faces I'm seeing are. So, what to say? It's just our online life. It's our online life. But just try to pay attention. So we finish up this. Like I said, I think we have only 30 more minutes together. Just a few more slides here on sample size calculation. So after you've you have decided that this is a sampling method I will use, you need the sample size. Though actually now thinking through it again, I'm seeing that actually you have to first determine the sample size. It can dictate the method. Remember, when you're using the systematic sampling, you need the sample size to calculate the K. You need the sample size and to be able to determine how you shall do the sampling. So logically, this should happen first. So, what is the sample size? The sample size is how many of the population are going to be part of the sample. That's what it is. How many of the population will be part of the sample. And there are two ways of doing that, of determining the sample size. One is a very simple method of just using a table proposed by Robert, Krajcik, and Morgan. So they just put a table there that you can get the numbers from. Or you can compute the appropriate sample size using a number of parameters. So we shall look at that. So basically, we're going to see how you get the sample size from a table, and how you get the sample size by an equation. So this, there is this table that Krajcik and Morgan put that tells you if your population is N, what should your sample size S be? If population is N, what is sample size S? So if population is 10, sample size should be 10. Population is 15, sample size is 14. Simple like that. If population is 75,000, sample size is 380. So just all you need is your population size. You look at the table, it will give you the sample size. That is a basic way of doing it using this Krajcik and Morgan. And then there is determining the sample size using a formula. And the formula has a number of parameters or factors that it considers. It has the size of the population, how big is the population, and how mixed it is with respect to the features of interest. This word heterogeneity means how mixed. Remember in the previous slides I talked about the word homogeneous, meaning there's one parameter. Hetero meaning there are many parameters, and the population is mixed. And then B2 is a sampling error. What is acceptable error? So the sampling error is the error that occurs in the survey results due to studying a sample instead of a whole population. So just the fact that you studied a sample of the population introduces an error. It is inevitable. It kind of goes with the territory. And it just has to be acceptable. Then you need a certain degree of accuracy or confidence. How confident do you want to be with these results? And another parameter that you use in determining the sample size, if you're using a formula, is the desired statistical value that you're looking for. Are you looking for the mean? Like you have a population and you want to know what is the mean, what is the average. The equation used there would be different from if you're using, you want to study and you find out different proportions. And we're going to look at this in detail. So these are the factors that determine the sample size, the equation. So if we have said here, you actually see here before that the factor that one of the factors is the statistical value. Either you're looking for population or you're looking for proportions. So depending on the statistical value, the type of statistical values may be vital, that may be vital to your research are mean and proportion. So when we say mean, we mean that the mean of a given feature. So like you're looking at age, you want to see the mean age, you want to see the mean height, you want to see the mean income. The equation you'll use a certain type of equation. And then if you want to know the population proportion that is in the percentage of individuals who fall within a certain category, you use another equation. So each of the above values requires a different formula for determining the suitable sample size. So if what you want to find out is the mean, like the mean age, mean height, mean income. Okay, Ruth, you have a question you can ask.
Okay, thank you, madam. I need to understand more on the population and the sample. Like if I'm conducting a survey on the secondary and primary schools in Kampala, and the stakeholders chosen are teachers and students. So the population from which I select the sample, is it the secondary and primary schools I will choose, or it is the students and teachers in those schools? What is the population in such a case?
All right, thank you, Ruth, for that question. Can we discuss this a little? Anybody who has understood Ruth's question and has an answer, something they're thinking? Okay. Okay, so Ruth, in that case, your population is the secondary schools and the primary schools, all of them, because the teachers are under this, all the teachers and pupils are under the schools. They're part of the schools. So your population is the secondary and primary schools. And there you're looking at a population that is mixed. It has secondary and primary. So you'd have to divide it first in that. Like, what is a percentage of secondary? What is a percentage of primary? Then after, you now know you would need to sample among those primary and secondary. Then after that, you get to know the numbers of pupils and teachers in them. And now again, you would have to separate teachers alone, the population of teachers, or the number of teachers, and pupils alone. You have your number of primary school teachers, you have number of primary school pupils, you have your number of secondary school teachers, you have number of you get the idea now.
Yes.
Yes, and then now you'd now determine the sample size for them. Best using that number. And thank you, Ruth, for that question. It has reminded me another thing also, a factor here that I was explaining. There's a fifth factor here, the research budget. Now, depending on the research budget dictates, indeed, you could use a formula and the table, and they give you certain values, but your budget can't accommodate them. So you have to fit your budget, sorry, the numbers within the budget you have, within the time you have. Okay. All right. Thank you, Ruth, for that question. Before this question, I was trying to explain what it means that you do sample size using the mean. So if what you want to find out is the mean age, mean height, mean income, then the equation you use is this one. S is equal to Z over E, all bracket squared, where Z is a number relating to the desired degree of confidence. 95, 99, these are the values that are normally used. And from the statistical tables, the value of Z is given. Now, remember, we did statistics. I hope I'm talking people who did additional math or sub math. And there's that statistics we did that had a Z value. Does any of you remember that thing? At least type 1 if you remember doing that kind of statistics.
No,
You didn't?
we did.
You did. Some of you did. Yes, when you're doing, all of you did. Good. When you're doing the either additional math or pure math, yeah, all of you did sub math. Yeah, you cannot come. I know. Yes, at least you should have. So this is the Z we're talking about. It is that value. That Z value that we had there in those statistical tables corresponds to a degree of confidence. So you have your Z value and this corresponding degree of confidence. And then E is an acceptable error. So you just need degree of confidence Z value plus acceptable error. You will use it to get your statistical, your sample size for okay, mean, okay, Kenneth. Yeah, Amy looks at it under business statistics. So that is the thing. That is the equation. Just only those two values, and you have your sample size. Then, if what you want to find out is the percentage of, or the proportion of a population that has a certain feature you're looking for, or that, yeah, then the equation is different. Is Z still the same Z that is relating to confidence? But now you have a new factor, P, which is an estimate of the proportion of objects falling into the target population. So you want to know, let's say, a half of the people, or what percentage of the people are rich, what percentage are poor, what percentage have that. So P is that value. So it is a proportion. It is an estimate of the proportion of objects falling into the target group. And then 1 minus P, this one, 1 minus P, is usually represented as Q. So the same equation can be like Z squared into PQ over E. If you compare these two equations, they are much the same. It says Z over E squared, just that now you have P times Q, part of that. So let's first have a small example here. So supposing we wish to evaluate a statewide extension program in which farmers were encouraged to adopt a new practice. So something was done. Farmers were encouraged to adopt a new practice. Now assume there's a large population of farmers, but we don't know the variability of the proportion that will adopt the new practice. So we therefore assume that P is 0.5. Maximum, minimum, basically half. Therefore, suppose we desire a 95% confidence level that corresponds to Z and a plus or minus 5 precision that is acceptable error. Then the equation is as follows. I hope that is clear. So this 1.96 came from the 95% confidence level, that is the Z value. The Z value is there. 0.5 is P, then 0.5 is Q, 1 minus P, giving you 0.5. Then 0.5 is the error. So you end up with this number of farmers. All right, I think I may stop here for now. I won't talk about sampling error. Unless you are not tired, but I think I should stop here. Are you following me, or I can stop here for today?
We can stop here for today.
All right, that's okay. We can stop here for today. That will mean tomorrow we have to finish this. Oh, but just a minute, people. Actually, 3 more slides to end. Why I want us to finish it off, so tomorrow I can listen to your work. Don't you have any work to show me? Or at least tomorrow we can discuss. Let me see. Okay, fine. Let's stop here for today. Though what was remaining is little, I'll finish it off tomorrow before I listen to you. Okay, thank you for coming. We shall meet tomorrow so that I can finish off this part and then I can see how far you are with your work. Ideally, you should be presenting to me your concept papers. The presentation is for you to get feedback from me. That's the aim. It's not like I'm going to be marking, just so you tell me where you are and see how to work on them. So you have at least something you have to share with me tomorrow morning. All right, let me conclude with a prayer. Do you have any further? Thank you for our class that we have had today. Today, power didn't disturb, my laptop didn't black out, anything like that. So I thank you. I pray of the students while they feel the things are many, help them to settle down, read them, and do their work. I thank you, Lord, in Jesus' name I pray. Amen. All right, thank you everybody for coming and for being patient. We shall meet tomorrow. Let me stop recording now.